In our everyday life we apply different forces either to move a body from its stationary state or to stop a moving body. The ball will remain at rest until the man kicks. That is, a force is needed to move the body from its resting posture. Now look at this. Here the moving car stops when a force is applied in the form of brake. From the examples we understood that a force is required to move a body from its stationary state or to stop a moving body. Sir Isaac Newton formulated first law of motion on the basis of this observation. First law of motion. Every body continue in its state of rest or state of motion until an unbalanced external force is applied. Next comes second law of motion. Rate of change of momentum is directly proportional to the force applied, and it occurs in the direction of force. That if F directly proportional to mv minus mu by t, where mv minus mu by t is the rate of change of momentum. Just rearrange the terms. Then we get F directly proportional to mv minus u by t. We know that v minus u by t is equation of acceleration. Substituting the term. Therefore we get F directly proportional to mass and acceleration. Now we can look this in detail. In this picture tell me for which mass we need to apply more force in order to move the body. Yes, you are right. Mass of 400 kilograms needed more force. As mass increases the force required will also increases. That is for 40 kilograms mass is less, so less force is needed. Thus we can say force is directly proportional to mass of the body. Next look what the man is doing. Just look at the movement of ball. When he applied less force acceleration was less. But when he hit with a greater force the ball had greater acceleration. Less force, less acceleration. Greater the force, greater will be the acceleration. Thus we can derive next relation, that is force is directly proportional to acceleration. From both the situations, we come to the conclusion that force is directly proportional to the mass, and force is directly proportional to acceleration. Thus we get F equal ma, which is Newton's second law of motion. Third law of motion. Law of motion defines: for every action there is an equal and opposite reaction. Imagine that a book is kept on a table. There are two forces acting on the book. One is the weight of the book that acting downwards, and the other one is force by table on the book. According to third law, the force exerted by book on table is action force, and force exerted by table on book is reaction force. For both forces magnitude are same, but directions are opposite. Now we can look at the next example of Newton's third law of motion. Here when man jump out of boat, the boat moves back. Now we will look how we can explain this on the basis of third law of motion. According to third law of motion, for every action there is an equal and opposite reaction. And here the man who step out of boat exert a force on boat which move the boat backward. And as a result of this a equal and opposite force is exerted by the boat on the feet of the man which pulls the man forward. Walking is another example for third law of motion. While walking our feet exert a force on the ground in one direction, and so the ground exert equal but opposite force on the feet in opposite direction. Rocket propulsion is a common example of this law. Here the action force is the pushing out of hot air gases produced in the engine, and reaction force is the hot gas pushing back on the rocket into the outer space. Some other examples include the recoiling of gun. When gunshots, a force is applied by the gun on the bullet which makes it move forward. Due to this force, an equal and opposite force is applied by the bullet on the gun, which lead to the backward movement of the gun. This backward movement of the gun is called the recoiling of the gun. This is one of the important example of third law of motion. Diving from a dive board and rowing of a boat can also be explained similarly using third law of motion. Note more applications of Newton's third law from our daily life in your science diary.